My name is Sanjeevan.
My name is Dinesh.
My name is Karthikeyan.
We are
from
from
SMK
SMK.
Data.
The title of our presentation today is Inverted Cone Solar Panel Booster. By using this invention, we can create an eco-friendly world where there will be less carbon emission. Eco-friendly inventions aims to not only produce affordable and clean energy but also to save many other major problems around the world. In specific, it aims to save space. The average size of a 250 watt solar panel is about 66 inches by 39 inches based on a recent research by US Sun Power. The average home in the US uses around 10,400 kilowatt of electricity per year. If you install the average 250 watt solar panel, you need around 28 to 34 solar panels to generate enough energy to power your entire home fully. Due to the speedy modernization works and innovative constructions happening worldwide, land spaces is said to be decreasing drastically every day. In a situation like this, we need to use available land space wisely to have a sustainable and more eco-friendly Earth. The demand usage of solar energy is increasing day by day and it will get tougher to fix average solar panels due to less land space. By using our inverted cone solar panel booster, less space is needed to provide more electrical energy in housing areas. This is made possible by our design which is compact and efficient. Thus, more electrical energy can be generated with lesser space. Furthermore, it can also save costs. On average, a typical 250 watt solar panel costs around $175 to $375 on average. For an entire solar panel system, the average homeowner pays around $3,910 to $6,490. Panels can cost as high as $13,600 too. This is very expensive for most of the people around the world. A lot of people don't want to fix solar panels at their respective houses because of this reason. We can't create a future with clean energy if this thing continues. Our inverted cone solar panel booster can generate more electricity with less solar panels, which means lesser money would be invested to create solar panels. Besides that, we don't have to have big houses to fix solar panels too. So, more money is saved and clean energy is produced at the same time. Last but not least, our eco-friendly invention is more efficient. The average commercial solar panel converts around 17 to 20% of sunlight into electricity. This might be enough now, but to meet future demands, this percentage wouldn't be enough at all. Our inverted cone solar panel booster is more energy efficient as it can convert more percentage of sunlight into energy compared to the normal commercial solar panels. This is mainly because of the cone design that we implemented in the solar panel, which increases the exposure of sunlight to the solar panel.
Edmund Becquerel first found the ability to create electrical charge from light exposure in 1839. Though these initial solar panels were too inefficient for even simple electric devices, they were used as an instrument to measure light. In 1873, Willoughby Smith discovered that the electric charge could be caused by light hitting selenium and published The Action of Light on Selenium in 1876 to describe his experiment's results. In 1954, this design was first used by Bell Labs to create the first commercially viable silicon solar cell. In 1957, Mohammed M. Atala developed the process of silicon surface passivation by thermal oxidation at Bell Labs to increase the efficiency of the solar panel. Despite this much of evolution in solar panels since 1839 till the present day, the current commercial solar panels are not efficient enough to maintain a green and environmentally friendly world in the future. Thus, we need to upgrade the current existing commercial solar panels in an innovative manner to ensure we have enough energy for a greener future world.
According to US Energy Information Administration, about 4,116 billion kilowatt hours of electricity were generated at utility scale electricity generation facilities to the United States. About 61% of the electricity generation was from fossil fuels such as petroleum, coal, and natural gas. About 19% from nuclear energy and 21% from renewable energy sources. From the 21% and only 2.8% of electricity is generated by solar energy. Electricity production generation generates the second largest share of greenhouse gas emission by research made by United States Environmental Protection Agency. Approximately 40% of the world carbon dioxide emissions are emitted from the electricity generation through the combustion of fossil fuels to generate heat needed to power the steam turbines. These gases that are produced from the burning of fossil fuels are the main factors for global warming and haze in the world. Global warming is a very serious problem, and if we did not take care of the problem now, the severity of the problem will be high in the future. As an example, the North Pole can be totally melt and make the entire planet sunk under the sea. Why our average commercial solar panels can't solve this global issue? It is because solar panels are very expensive for most of the people. It takes a lot of space, and on top of that, it is not an hazardous product and used during the manufacturing process of solar photovoltaic systems, which can indirectly affect the environment. Our invention can reduce the amount of toxic materials being used and solve other problems that I mentioned earlier. The invention modifies the design of an average solar panel by changing its shape and structure and by implementing various material inside. The invention will look like a box that have 6 cones in it. Every single cones in the invention will have 3 mirrors and 3 panels in it. Above the cone there will be a solar concentrators. First, mirrors have a natural ability to reflect light, so when we fix mirrors in the cone, the structure won't let the sunlight to escape away from the cone. On top of that, the sunlight will reflect so fast in it that the absorption of sunlight will be high. Most solar panels are designed with anti-reflective glass from surfaces and only reflect about 2% of incoming light. Mirrors in this cone will help the panels by reflecting all the light in it. Mirrors in the panels also can make sure the panels are letting sunlight throughout the day, which will increase the efficiency of solar panels. Secondly, we fix those panels and mirrors in a cone structure. It is because the amount of sunlight escaping from the structure is less, because the light will be traveling inside the cone structure for a long time because of its shape. Thus, solar panel will be in contact with sunlight for a long time. Moreover, we have fixed 2 solar concentrators for each cone in the panel that can focus light on the panels and on the mirror. This can increase the amount of energy generated because of its ability to absorb and focus all the energy to a narrower space. Lastly, the gaps in the solar panel boxes will be filled with small solar energy storages that will help the electricity to be supplied through the day and night. By this, we can make sure we get enough electricity even though the weather is not optimal for the solar panels to generate electricity.
There are several future plans for this project that will bring positive impacts if implemented in the near future. Firstly, this invention should be implemented in all industrial areas at a larger scale to generate sufficient electricity to power those areas. Besides that, this invention can be released in compact sizes to be used as chargers for electrical devices at outdoor situations, such as solar power phone and laptop chargers. Lastly, this invention should be installed in housing areas to provide electrical energy for all houses efficiently. In a nutshell, this invention has the potential to save our planet Earth from having lack of energy sources, as this invention is powered by a renewable energy source, which is solar energy. If this invention is used commercially and widely, it can also prevent global warming and ensure a sustainable and eco-friendly Earth.